we have covered the chapter 3, all about, okay. Chapter 3, you have binomial probability distribution, you have Poisson probability distribution, and then you have if let's say your n is greater than or equal to 30 and your np is less than 5 or your nq is less than 5, then you can approximate from binomial solve using Poisson. Okay, so what that we have covered so far. And the last part will be normal probability distribution. Okay, and for normal probability distribution, we are going to look out on how we can solve some experiment that following the normal features. Okay, when you have that particular case, you are going to solve that probability distribution using the normal features. Okay, and for that, we also have the approximation of the two that we have covered before. That will be binomial to normal and Poisson to normal. Means that once we have covered for normal, we will see how we can solve our normal distribution problem, and we are going to look on how we can transform from binomial to normal and then from Poisson to normal. Okay, so that will be more or less our coverage for today's class. Okay, so this will be the thing that we are going to cover today. Okay, so far, do you have any questions before we begin, class? Okay, if you don't have any question, what we have discussed before regarding the distribution of our experiment, okay? Remember last time when I said about the Poisson and binomial problem, when you have n greater, if let's say you increase the n with the remaining p constant, okay? Or you have constant n, okay, and you increase the p probability of success. What happen is that it will converge to what we call symmetric distribution, right? So we have discussed that before. And the other one will be when you have lambda and the lambda is increasing. At certain point, the distribution of that particular Poisson also will become symmetric. Okay, so that's why, having said this particular what we call features, we are going to have next how we can perform this particular approximation from binomial to normal and from Poisson to normal. And before that, before we can even doing this, we need to understand the whole thing about normal probability distribution. But of course, in your lecture today, I will just simplify everything in such a way that I'll just touch on the surface of what is normal probability distribution is all about and how we can solve them. Okay, so let's say if a continuous random variable x has probability distribution graph that's symmetric or bell-shaped. Now, the other word that you learn today, apart from symmetric, okay, you have also what we call bell-shaped, or we call it as normal. So these three terms share the same meaning. So when people say about normal distribution, symmetric distribution, bell-shaped distribution, they are all talking about this particular distribution. Okay, that looks like exactly this one. It's very symmetric. Okay, and the distribution of the random variable is called the normal distribution, and the graph is called normal distribution curve. So this is how it's look like. Okay, and the center of the normal curve is what we call the mean. Or if we are using the notation of the population, it will be this one, mu. Okay, we call it mu. And mu reflect the mean of that particular x random variable. So if you have any question, just stop me. Okay, since we are going to make it a bit faster so that you can finish the class early. Okay, so what are the characteristics of normal distribution? And as what you have in binomial, there will be 4 characteristics of binomial distribution. You have 1 characteristic under Poisson distribution. What about normal distribution? Okay, the first one, it shall be bell-shaped graph. Okay, bell-shaped means it is symmetric. Okay, the half part from the left, from the middle to the left, and the half part from the middle to the right are exactly the same. It's a mirror of one another. Okay, and the mean, median, and mode are equal. What does this mean? Okay, we are talking about, these are called the measure of central tendency, MCT, measure of central tendency, where all the measure, that is the mean, median, and the mode, reflect the middle value. Okay, so this is what it meant by the second characteristic. The measurement of the center value will always be equal to the median and mode, but for our case, for the normal distribution, we are going to refer the central value as the mean. Okay, the location is determined by the mu, the mean. Okay, the location means that if, let's say, you have x, the mean of x is equal to 75, then you are talking about the mean of this distribution, the center value is 75. If, let's say, you got mu2, okay, mu2 is equal to 90, for example, then it will shift to 90, where this is your 90. So that is why the normal distribution will be determined by the value of the middle value, that is the mean or the mu. And the spread is determined by the standard deviation sigma. Where is sigma? From the middle value, okay, to the left or to the right is what we call the standard deviation. The bigger the standard deviation, the bigger the spread. So if, let's say, you have sigma 1 is equal to maybe 4 and sigma 2 is equal to maybe 6. If you plot them, okay, where the mu1 is equal to maybe, for example, let's say 30, and mu2 is somewhere 35. Okay, so let's say this is the distribution of the first one. The mean is 30 and the spread is 4. Okay, and you have the second one. Okay, the mean is 35. So let's say I'm using my green pen. Okay, so the mean is 35 and the spread is 6. So the spread is 6 means that the distribution even flatter and a bit bigger than the first distribution. So this is what it meant by the sigma and the mean value. And the random variable has infinite theoretical range, means that the random variable x can be of any values from negative to positive value. So if, let's say, you have negative value over here, positive value over here, your x value can be of any values. Okay, it can be positive or it can be negative. Any questions so far, class, for this part? Any question?
No,
Okay.
no.
Okay, thank you. Now we move to the next part. Okay, I think this one is just a representation of the things that we have just discussed just now. So if, let's say, we have the mean, let's say we have 3 random variable and they are reflecting the same position of the mean. So if I plot the mean value, okay, so the mean, let's say this is, for example, maybe 70. Okay, so for the spread of each of the random variable, it will be different. So the spread for yellow distribution, okay, so let's say this is sigma 1, this is sigma 2, and let's say the green one, mu is equal to, let's say, 80. So in this case, this is sigma 3. So in this case, what we can comment is that, okay, sigma 1 is less than sigma 2. Okay, sigma 3 is greater than sigma 1, sigma 2, sorry, and sigma 2 is greater than sigma 1. And in our case here, sigma mu 1 is less than mu 2. So these are the information that you can extract from this particular distribution. So from varying value of mu and sigma, you have different normal distribution. So what are the properties of normal distribution then? So the curve is bell-shaped. The mean median located at the center distribution. It is unimodal. Unimodal means that you have only one peak. Okay, one peak only. Unimodal. The curve never touches the x-axis. So that is why if you look at the distribution of this normal distribution, the curve will never touch x-axis. Okay, it will never touch. So means that it will above the x-axis. And the total area under the normal curve is equal to 1, or we can transform that into 100%. So remember back then when we discussed about binomial and Poisson, normal, the probability value, maximum probability value for binomial or even for Poisson will equal to 1. The same goes to normal distribution. So the curve, the area under the curve, okay, will give you probability value that is equal to 1. So next, in our case, in normal distribution, the way we find the probability value will be based on the area under the curve. So this reflects some of our example in continuous distribution in chapter 2. Last time we discussed about chapter 2, when we need to find the probability value, sometimes we need to integrate the function. So this is more or less reflect the same meaning. Okay, so that will be some of the properties of normal distribution. Now, instead of normal distribution, why we need to understand about the standard normal distribution? Now, what we have before in our normal distribution, x will be distributed following normal, and the parameter will be mu and variance sigma squared. So this is the population mean, and this is the population variance. Okay, so that will be the parameter for normal distribution that contain the mean and the variance of the population. So in this case, it is not mentioned somewhere. Now, this is what we call normal distribution. Now, knowing that our normal distribution may range from different value of sigma and different value of mu. Remember, if you have, let's say, x1 following normal and 75 and let's say 5, you have x2 normal, let's say 30 and 4, blah blah blah, until let's say x100 following normal. Let's say this one is 25 and 10. So in this case class, how many normal distribution you may have for this case class? Can someone tell me how many distribution you may have?
100.
Yes, you are going to have 100 distribution. Okay, you have to plot one by one. So how are you going to do that? Since we are going to make things simple for us to solve them. That's why they introduce what's so-called the standard normal distribution. So whatever distribution you have in your problem, you are going to transform them into standard normal distribution. So when you have standard normal distribution, you are going to refer to that one standard normal table only. So everything will be simplified for you. So in standard normal distribution, okay, you will no longer have x. Okay, x will be transformed into z. Z is your new variable. that reflect the standard normal distribution, and Z is following normal with mean equal to 0 and sig variance equal to 1. Okay, so this is the first understanding that you have to remember. Standard normal distribution. So that is why we have standard normal here. Someone is not, someone please mute your microphone. I'm not sure who. Can you please check your microphone? Someone is not muting your microphone. Okay, that is why class here. The standard normal distribution will have the parameter mu is equal to 0 and the variance is equal to 1. Okay, and this is called the standard normal distribution. And how does this distribution looks like? This is the way we write the standard normal distribution with the mean 0 and the standard deviation 1 or variance equal to 1. So class, having said this, you have different mean, different variance or standard deviation. Everything will be simplified or solved using this particular distribution. Okay, by using this particular distribution, you can solve any given normal distribution using standard normal distribution. Okay, so numerous continuous variable can have distribution closely resemble the normal distribution, and the normal distribution can be used to approximate various discrete probability distribution. We are going to look at that afterwards. Okay. Now, what are the things under standard normal distribution that you need to understand? Okay. Now, class, how does this conversion from X following normal with parameter mu and variance sigma squared, we transform that into Z, where Z is following still normal, but the mean is equal to 0 and the variance is equal to 1. So how does this conversion takes place? So this is how, class. Okay, the conversion from X to Z. Okay, later on, when you are given the condition of your problem in terms of the normal distribution, the original normal distribution, when you transform into Z normal distribution or standard normal distribution, you have to use this conversion. Your X, okay, the mean of X given, for example, maybe at the beginning is 35. So conversion from X to Z, okay, will take this particular value, 35 divided by the sigma, and depending on the number, the value of X given in your problem. So this will be the keyword of transforming from the normal distribution to standard normal distribution. Okay, so remember class, from normal distribution to standard normal distribution. Now, example, how to use this particular or how to solve this particular problem. Class, how does your distribution looks like? This is how the distribution looks like. And this will be the normal table or standard normal table that you are going to use for your problem solving. Okay, this is the standard normal distribution. And what are the information given in your standard normal distribution? Remember class, last time we said the area under the curve will never touch the x-axis. But in this case, more or less it's look like it is touches the x-axis, but it is not. Actually, it does not touch the x-axis. So this is the x-axis. So this is the y-axis, but in our case, the y-axis is the function of our normal distribution. But in this case, the function is written as this one. Okay, this is the function. Now, where is the probability value? The probability value given in this particular table is reflecting this brown region. Okay, so your Z value from 0.00 until 3.90, or if you wish to find 0.05, you go for 0.00 and look for 0.05. So this is where your Z value 0.05 is giving you the probability value. So 0.0199 is your probability value here. And your Z value here is 0.05. Okay, class? Please make sure you understand that. What if my Z is equal to 2? Let's say my Z here is equal to 2. Go for 2.00. So this is the probability value. So it should be larger than this one. The shaded area brown here is 0.4772. So for 0.4772 is inside this particular area, and the Z value here is equal to 2. Okay, class? So you have Z value for the x-axis value and the probability value, all the value inside this particular table are reflecting the probability value in the brown shaded area. Okay, so that's how we refer to our table. Now we get back to our note just now. Let's say you need to determine the probability of Z. Okay, straight away we are talking about standard normal Z taking place from 1 until 2.70 and Z less than negative 0.94. How we are going to look for this value? The interest is finding the probability value. So let's say you forget about this first. Okay, you forget about this first. Let's say, look how I solve this using our understanding based on our discussion just now. Now, when we talk about standard normal, okay, the middle value is 0. Okay, because we know standard normal is Z following normal with mean 0 and standard deviation or variance equal to 1. Now, you need to find the probability value for 1 until 2.7. So since I know that 0 is here, so 1 is somewhere over here and 2.7 is much bigger. So let's say this is 2.7. So the shaded area that you need to find will be this shaded area. Okay, so since we are going to use our table just now, how are we going to solve this? We know that, class, since we have bell shape symmetric, means that half of the probability distribution is given by 0.5. The other half is 0.5. So that will be our first understanding. Adding the two area, you will get one probability value. Now, how are we going to solve this? Okay, go back to our table just now. Okay, class. See, the given probability value is from 0 until Z value. 0 until Z value. So how are we going to use this concept to solve our equations? Now, looking at this particular equation, we know that we can find from 0 until 2.7 as the biggest area, area number 1, deduct with this area. That will be area number 2. Okay, so if let's say I take the area, the red area, okay, minus the area of the green one. Okay, you are going to get your shaded in blue. Correct, everyone, class? Do you understand here, class? Anyone who got problem? I need to hear someone says okay. Is it okay?
Okay, Doctor.
Okay, Doctor.
Okay, if okay, then I will proceed. How are we going to use our table then? So if I were to write down, okay, if I were to write down the way it is written, so P1Z from 1 to 2.7 is given by P0 Z until the biggest region is 2.7 minus P0 Z until 1. Okay, so that will be my first understanding in terms of what minus what. Then from this one, I need to look at my table. From 0 until 2.7 means that our Z here is equal to 2.7 and our Z here is equal to 1. So look for 2.7 and 1. Okay. So if you look at 2.7 and 1, so for those who have downloaded the appendix that I have attached in your e-learning, you can open your standard normal distribution from that particular appendix. Okay, the first one is 2.7. So 0.7 is somewhere over here. So this is 0.07 and I need to look at 2.7. So 2.7, right? Yeah. 2.7, oh, this is 2.77. I'm looking for 2.7. So I look for 0 column here, the first column here. So 2.7 is 0.4965. Okay, so this is the value, the biggest region. Minus 1 is 0.3413. Okay, 3413. Write down the value. So you will get 0.4965 minus 0.3413. So you will get what, class? Can someone please calculate for me? What is the value?
0.1552.
Okay, thank you. 0.1552. So the probability value that we are looking for this particular region is the shaded in blue, 0.11552. So that is the probability value. Okay, I wish everyone can understand that. The next question is for, okay, we know that standard normal is mean 0. And you need to find where Z is less than. And it is negative value. Okay, so let's say this is negative 0.94. And you need to look for region that for less than. So this is less than. Okay, so this is the first understanding that you need to have from looking at the question. Next, knowing that I need to refer to my standard normal table that is given the region from 0 until what value, Z value. So since this is a symmetric distribution, I can bring this to this particular region. So I have 0.94 for positive value. And the region that we are looking for is this particular region. Okay, since half of the value, so half of the probability is 0.5. Okay, by looking at this particular value from the table, we can get our value here. So how are we going to write that in terms of the solution? So P Z less than or equal to negative 0.94 is equal to 0.5, the half of the area, minus P0 until Z 0.94. Okay, so we have 0.5 minus from 0 until 0.94. So look from the table, 0.94. 0.94. So 0.94 will give you 0.3264 minus 0.3264. Can someone please calculate this? What is the value, class?
0.1736.
Okay, thank you. So the area that we are looking for, okay, the probability value is 0.1736. Okay, class? So that's how we solve for directly if you are given the standard normal value. Okay, what if you have another question? From 0 until 1. Can you please do it, class? You are having standard normal. How I know that this is standard normal? Because you are given Z value directly. So mean is equal to 0. From 0 until 1. So you are looking for this particular region. What is the value, class? And the second one is, let's say we solve one by one. Okay, from 0 until 1. 0 until 1. 0.3413 directly from table. So this one is 0.3413. Okay, so the second value, the second distribution, okay, the mean is 0 and you are looking for from 0 until negative 2.51. So this is the Z value and you are looking for this particular region. Okay, so knowing that this is a reflection and the distribution is reflecting the positive region, so goes back to your, let's say, sorry for the not really nice distribution. So you are looking for this particular value. So from 0 until 2.51, 2.51, 2. Let's say 2.51, 1 is the second column, 2.51. So it will be 0.4940. So this one directly is 0. Berapa tadi? 0.4940. Okay, class? Did you get it, class? Understand everything? Now,
Okay, Doktor.
ya, ada yang nak tanya ni. Okay.
Macam table tu kan, doktor baca yang bahagian yang belah atas, doktor baca macam mana, tak faham.
Ni macam ni. Sebab dia nak tanya 2.51 kan?
Ya.
2.51, 2.5 ada kat sini. Jadi kalau nak 2.50, saya pergi kat kolom kosong. So dia akan jadi pada kolom 1, 2.500. Kalau saya nak baca 2.51, saya pergi cari yang second decimal tu, saya pergi cari yang 1. So 2.51 is here. Kalau saya nak cari 2.59, saya cari decimal point yang kedua 9. So dia akan jadi 2.59, nilai dia yang ni lah. Okay, so that's how we move. Okay.
Understood.
Okay, thank you for the question. Okay, now let's move to the next question. So I think that exercise. Yang ni boleh tak cuba? Cuba dalam few minutes, maybe 1 to 2 minutes. I think soalan 1 saya rasa you boleh buat sendiri sebab direct. Saya pilih soalan lah supaya kamu buat yang mana kamu kena faham sikit konsep dia. I think saya nak kamu cuba buat yang nombor 3, nombor 4, nombor 3, nombor 4 dengan nombor 6. Boleh tak cuba sekarang? Yang lain tu senang. Yang 1, 2, 5 tu straightforward. Saya rasa kamu tak ada masalah nak buat. Cuba buat 3, 4, 5. 3, 4, 6, sorry. Very quick. Siapa yang tak ada table tu boleh buka appendix yang saya beri dalam e-learning ya. Okay. Saya cuba kita bincang sama-sama ya. Okay, we try question number 3. Question number 3 says that I like to draw the distribution so that I can imagine where is the region that we are looking for so that it will be easier. So those who have already understood, later on you don't have to waste your time in drawing the distribution. But if it is easier for you, then do it. Okay, so we are looking for 0.44. The mean is 0. 0.44, let's say, is over here, greater than. Okay, so this will be what? We know that half of the area is 0.5 minus this particular X region. So what is the X region is giving you the probability value? So 0.44, 0.44. So you get 0.17. Okay, 0.17. So what is the value, class?
0.33.
0.33, correct. Now, what about question number 4? Okay, you have standard normal distribution, the mean 0, and the value that you are looking for, Z is equal to negative 0.23, and the region is greater than. Okay, directly from this particular drawing, you know that, okay, it consists of 0.5 and the other one is from 0 until 3. So you need to add some more the region for 0.23 where you have this particular probability value. So for this particular equation, you will have 0.5 plus P0 Z until 0.23. So that will be 0.5 plus, what's the value from 0 until 0.23, class?
Uh, 0.0910.
Yes, correct. 0.0910 to 3. Let's check. 0.23 to 3. So 0.0910. Okay, so you will get equal to 0.5910. Okay, what about this one? Number 6. 0, negative 0.71, negative, Z value is negative 0.71. So we know that this is 0.71. So this will be what, class? 0.5 minus P 0 until Z takes value of 0.71. So 0.5 minus, what is from 0 until 0.71?
0.2611.
2611.
2611.
So what is the value for the probability? 0.5 minus 0.2611. So it will be 0.2. 389. Correct. Okay. Now I imagine everyone have understood how to find the probability value using one standard normal only. Okay. Now let us move to question where you need to understand in terms of, before that, you have to understand the next table on the upper tail probabilities. And before that, you have some note here. I think this one is just to remind you what is the interpretation of the probability value, if it is close to 0, if it is close to 1, or if it is near to 0.5. So if it is close to 0, highly unlikely to occur. Means that probability to occur is very small. Close to 1, highly likely to occur. Most probably it will be happening. Near 0.5, middle to occur, or like likely to occur. Okay, so this one, the other word is likely to occur. Middle to occur, macam pelik, no? Likely to occur. Kalau lebih daripada 0.5, maknanya close to 1 is highly likely to occur. Now, there will be second understanding that you need to understand about the standard normal. Because why, class? You, instead of having the probability following this particular understanding, there will be one table that reflect the upper tail probability value. Okay, when you have upper tail probability value, you are referring to a different table that reflect the same value. You are still talking about the probability value for the shaded area here, the brown one, and the Z value. But now, your Z value is depending on the shaded in brown probability value. So if let's say I name this as alpha, so according to this particular probability value or alpha, I can find the Z alpha value that reflect this probability value. So that's why when you look at your table, your first column is reflecting the probability value. So if let's say you have your pen, please note somewhere, alpha is the probability value. If you are looking for alpha 0.00, then the value, the probability is 0. If you are looking for alpha 0.05, where does my alpha? My alpha is 0.05, is somewhere over here. 0.005, sorry, even smaller. What is the value of Z alpha? My Z alpha, that is here. My Z here is 2.5758. So this value is 2.5758. If let's say I'm looking for bigger alpha, the biggest is 0.4. Let's say I'm looking for alpha 0.400. So let's say even bigger here, this value is 0.400. What is the Z value here? The Z value is 0.2533. So class, bear in mind, this is probability value, the first column and the first row. And the value inside the table are all reflecting the Z alpha value. Reverse, in this particular table, your Z value is in the first column and the first row, and the probability value is inside the table. So you have different table and different value that you are referring to. Now, what if I have question that need for me to use this particular distribution table, upper tail table? So let us look at few example. Okay, so this is how it looks like lah kelas. So macam tadi, maknanya dekat sini alpha ini diberi dalam kolom 1 plus row 1. Yang Z alpha ini dalam table. Okay, in your table. Suddenly PM pula in table. Okay, now let us look few examples so that we can understand whatever question given to you, I can still look for the probability value as well as the Z value or the X value at the X axis. Now, upper-tail probabilities are or area of the distribution of Z have also been tabulated. Okay, so an entry in the table specify the exact alpha and the area of the probability value is given from the alpha value. Now, let's do few example before you can do your own exercise. Okay, now we have, let's say, begin with A. We have PZ greater than Z alpha, where the alpha is 0.25. If I draw, this is 0, and this is my alpha is 0.25. So what is my Z alpha here, or Z 0.25? Look at our table, 0.25. Okay, alpha is 0.25 is column here, this column, 0.25. Sorry, 0.25 is from this first column, sorry class. 0.25 directly from this particular first column. So the Z alpha value, the Z value is 0.6745. Okay, so 6745. So the Z alpha value is 0.6745. Greater than, because greater than, okay. So B, you are looking for Z that give you alpha 0.36. Okay, if I draw, now, bear in mind, sometimes you have to test, okay? 0.36 is very small probability value. If, let's say, we know that middle is 0, if, let's say, my Z alpha is here, okay, is it possible that 0.36 is covering this class? Is it possible? Probability value here, is it correct? Class, is it correct? Nilai probability dia 0.36, tapi region dia kalau kita tengok kat sini ni, is it possible?
No, not possible.
Yes, so this is where we have to test. Or in this case, wrong, because the area is too big. So what if we test another one? Okay, we test the other Z alpha. Let's say I have 0 here. 0.36 is very small. Let's say this is Z alpha, but in this case, Z alpha will be negative. So this is 0.36. Yes, makes sense. Okay, so in this case, we know then our Z alpha will be negative value. So since we are reflecting a symmetric table, so again, we can bring this to the right hand side. So this is where we have Z alpha and this is 0.36. So what is the Z alpha given? Can someone please tell me from your table, what is Z alpha? (0.36). What is your what is Z alpha given here, class?
Kosong point 3585.
Sekejap ya, soalan B. Kejap. Soalan B, 0 berapa? 0.3585. Yes, correct. Okay. 0.36. Look for 0.36. 0.36. 6 kat mana? 6 dekat kolom yang ada page ni ya. 0.36. 0.36. Oh, 36 terus directly, sorry. Kat sini terus ya. Sorry. In the first column is 0.3585. So the value that you are looking for Z is equal to, okay, Z alpha is equal to negative 0.3585. Okay, what about question C? C, you are looking for, okay, 0 here, Z alpha. If let's say Z alpha is over here, is it possible that this is the area class?
No.
No, this is wrong. What about this
No, no,
one?
no.
Yeah. So what about this one? Z negative value and it is greater than. So greater than, yes, makes sense. Because if this is the Z alpha that we are looking for, then this will give you 0.5. What about this one? Can someone please tell me what is the Z alpha here? How do I look for Z alpha? So look for, macam kita reflect lah. Kosong, Z alpha kat sini. Alpha yang kat sini berapa nilai dia? 0.9, sorry, 0. Sorry, macam mana nak senang? Macam mana nak senang? So kalau dekat sini is 0.5, so area kat sini ni berapa ni? Kalau kat sini ni 0.5, what about this one? Area kat sini ni?
0.483.
483. Macam mana dapat? Sebabnya campur dua ni kita dapat nilai ni. Ataupun okey, nak senang lagi, kita terus tolak. 1 tolak 0.983 dapat berapa? Dapat apa?
0.017.
0.017. So this area probability value kat sini yang kita cari ialah alpha dia is 0.017. And we know that we are having negative value of Z alpha. So tengok pada table 0.017, 0.017, 0.017, 0.017. 2.1201, betul tak? Betul tak? Faham ya semua? Dapat, you got 2.1201. So the Z alpha that you are looking for in this case is negative 2.1201. Okay? Do you understand this? C class, number C. Do you want me to write it properly in terms of the jalan kerja? Is it okay? Okay ke semua?
Sorry, Doctor.
Yeah.
Can you repeat C, please? Because I have bad connection and it gets me
Okay.
out of
Okay.
class.
Let me repeat again. We know that we are looking for 0. We are looking for this particular region, right? 0.983. It will be very big. And the what we call the sign given is that Z should be greater than Z alpha. So if we choose Z alpha over here, it will be not sufficient, not suitable, because the probability value is very big, even larger than half of the region. So this is wrong. Okay, so the one that we are looking for is actually at the left hand side, where the Z alpha will be a negative value. So this is where if we are looking for the upper tail table, so we are looking for this particular region transform into this part, that will be Z alpha over here, and this one will be, what is the value? It should be, easiest way, it will be 1 minus the given value, 0.983. 0.983. Okay, so this is your alpha here. So what alpha value that you are looking for? 1 minus 0.983 will give you 0.017. So this is the area that give you this particular region. Okay, so in this case, what is Z alpha positive? Z alpha positive, looking for from your table 0.017, 0.01, look for 7 in the third decimal point. So this is the Z alpha value. Okay, 2.1201. So this is 2.1201. Since we are looking for this particular PZ greater than Z alpha 0.983. So we know that this is the Z alpha that we are looking for. So in this case, Z alpha will be negative value. Okay, clear? Clear, class? Okay. So,
Yes, Ustazah.
okay, thank you. So for Z alpha less than Z alpha, yang ni boleh tak cuba? Boleh tak? D. Siapa yang tak dapat nanti bagi tahu saya. In 1 minute, can you please try for question D? Z less than Z alpha is 0.89. So D 0, P Z greater than Z alpha is equal to 0.89. So definitely Z greater than Z alpha. If let's say Z alpha is over here 0.89. Yang ni saya dah jawab apa tadi? Belum kan? Okay, so this is wrong. So look for another Z alpha where you are looking for the area greater than. So let me shade the area using red color. Okay, makes sense. So this is 0.89. So look for Z negative. What is the value here? Very quick, can someone please tell me what is the Z alpha value? So if the bigger area is 0.89, what is the smallest area here? Apa area yang ini, kelas?
0.11.
Okay, 0.11. Okay, so 0.11, what is your? What is your Z alpha value?
1.2265.
1.2265. Negative value, right? Saya bagi soalan betul ke? Allah, saya bagi soalan salah. Dia less than ya. Allah Akbar. It's okay lah, I change the question. I change the question. Okay. So for greater than is this one. But for less than, okay lah, kita buat jugalah. Less than. So yang ini untuk greater than. If let's say we have less than, okay, we are looking for PZ less than Z alpha is 0.89. Apa yang salah ni? Greater than 0. Less than, betul. Less than, betul lah. So 0 is here, Z alpha is here. You are looking for bigger area, that will be this part. Okay. So you know that this one is 0.89. So this one is 0.11. So what is Z alpha here, class? Is 1.2265 directly. Okay? Okay, finish with that. I think exercise this exercise I think is just the same, just to give you the feelings for this one, the area of Z to the left. So this one is reflecting, you have standard normal from 0.9750, the area to the left. So ini soalan, what is the probability value here? Okay, the area between, yang ini guna table 1 this is not upper tail, ini table biasa. Yang kedua from 0 until 0.4750. So this is the area directly from table. Okay, yang ini saya minta kamu buat. Okay, now we want, this is the most important part class, because your given question will not be given in terms of standard normal. It will be given in terms of normal distribution, the original distribution of the problem. Okay, so for this particular case class, okay, see, you will be given, so let's say this is the simplest question given to you. Suppose X is a normal distribution, so that here you can write X is following normal with parameter mean mu is equal to 25 and the variance is 25. Okay class, bear in mind, please make sure that you get the correct information to be used when you transform into standard normal. Remember, this always be the mean and this will be variance. And when you look at your transformation X to Z, it is reflecting standard deviation. Okay, so in this case, so please, sigma will be what class? Using variance 25, what will be your sigma here? If your sigma squared is 25, then sigma is what class? Sigma is what class?
5.
Yes, 5. So these are among the things that will be meticulous, should be meticulous for every student. Sometimes student will use the given value in the variance, so everything will be wrong then. Okay, so let us find the answer for these particular questions. Okay, now if I were to draw the distribution of the original X, okay, so your X will be distributed normal with the mean 25. This is the mean. And the variance is 5. Now, transform that into Z. So how what will be the way the process is being done? Okay. So P 24 X 35. Okay, you need to find the probability that the mean value will fall between 24 and 35. So this will be the area that you need to find. Now, what if we transform this into standard normal then? Okay, so the way we transform, so it become P, remember this one? So the given X is 24, the mean is 25, and the standard deviation is 5. So when we transform, when we apply this, then X become Z. Okay, then follow again 35 minus 35 divided by 5. Solve for this. So what is this one? What is the first term here?
Doktor, mean untuk 35 memang 35 lah.
Huh?
Mean untuk 35 memang 35.
35 minus 35 lah.
Ya betul. Sebab dia bagi kat sini 35. Kat sini, oh sorry. Oh sorry. Cakaplah mean 25. Saya silap tulis lah. Sorry. Okay, 25. Thank you for the correction. Okay. So what's the value here? You got negative right here? Negative. Negative what class? Is it negative 0.2?
Yeah.
Okay, then Z, what about this one? Is it 2? Yeah, correct. So this one, this is the original distribution. So if you transform that into standard normal, see, it becomes 0. The one that you are looking for is from negative 0.2 until 2. So these are all the area that you are looking for. So having the initial understanding that we have just discussed before, so this one will be the area, the first area here plus the second area here. So can someone please tell me what is from 0 until 0.2? So means that you will have from the area from Z0 until 0.2 plus 0 until 2. So from 0 until 0.2 and then plus 0 until 2. So what is the value from 0 until 0.2? Can you please? Someone? Which table that you need to refer? This is the first table, not the upper table. So looking for 0.2, 0 until 0.2. So just look at 0.2, 0. So 0.0793. So 0.0793. What about 0 until 2? Can someone please?
0.477.
Yes, correct. So this will give you 0.5565. Okay? Okay, class? What about question 2? Question 2,
Doktor.
Ya, ya.
Macamnya kalau kata kita punya P tu negatif 0.2, kiranya kita tak kita positifkan ke?
Ya, betul. Sebabnya, why we use positive value? Because everything, the table is reflecting this particular region. So, whatever negative value you got here, bring to positive value, it will reflect the same area for negative value. Okay? So, what if for the second question? Find, okay, P x greater than or equal to 20. So this become P z greater than or equal to 20 minus 25 divided by 5 is equal to what? So if you no need to draw the distribution untuk yang normal, standard normal untuk equation ni dia akan jadi 0 here, 20 minus 25 divided by 5 dapat apa? Negatif 1, right? So negatif 1 Z alpha Z dia ialah negatif 1 greater than ni. So kadang-kadang kena lukislah supaya kita nampak dia punya region tu kat mana. So if Z is greater than negative 1, so it will apa jalan kerja dia kelas? Ini dah halfway, so 0.5 plus P 0 until Z taking place from 0 until 1. Bawa ke sini 1. So dapat berapa ni kelas? 0.5 plus what?
.3413.
Yes, 3413. So your probability value is 0.8413. So you got the answer. Okay. Now, siapa yang ada periksa tu, for those who got exam, I can dismiss you now. But please watch my video for the rest of my discussion with the class. Yeah. So please, before you leave, those who have exam, please fill in the attendance form. Okay. So for the rest, can I continue class? Is it okay?
It's okay.
Okay. Now, this question is a bit different because it will require your understanding by using the first table and the second table. Okay, so and this is the kind of question that will be asked usually during your assessment. Okay, so basically for this particular question, sometimes we will want you to solve using your own what we call your own handwriting, where you have to submit your process of getting the answer. Okay, now let's say we refer to this particular example. An assessment is used to measure a person readiness for college. Okay, so you are referring to an assessment marks, I believe. Okay, the mathematics score in the test are scaled to have a normal distribution with mean 500 and standard deviation of 100. Okay, so that will be the given information. Now, first thing first, what should you understand is that please understand the given question. If it is normal, then I know that we are looking for x random variable that follows normal. Okay, now the first question, define the random variable and state the distribution. So how do we define? The same way as we define the binomial and Poisson. So for normal, this is how we define the random variable. So for A, x is equal to, we are talking about mathematics score. Okay, so in this case, is the mathematics score. Is the math score in the test. That will be your random variable x, how we define that. Okay, then x is following normal with mean 500 and standard deviation 100. Class, remember the way we write must be correct. When we write, we need to write the variance. So the variance will be what, class? Is it 100? How do we write that variance?
100 power of 2.
100 power of 2. Yes, correct. So this basically, if it's a subjective question, we will begin with defining the random variable x, then write down the correct distribution of that particular random variable. If you write down only 100, then you will get wrong. Okay, so please be careful on how you write your information. Done with A. Now B. What is the probability that the people taking the test will score below 350? So if I were to draw the original normal distribution, the mean is 500. Okay, and you are talking about below 350. So let's see, if this is 350, you are looking for area, this one. Okay, now how do we do that? Transform into standard normal. So the first that you need to write is Px less than 350. Sometimes it will bring you half mark or 1 mark for that one. Then what? Transform into standard normal. So standard normal, it become Z. Then less than, then transform into Z, it become 350 minus the mean, that will be 500, divided by the standard deviation. What is the standard deviation? 100. Can someone please calculate? What is the value here?
Negative 1.5.
Negative 1.5, correct. So if we were to transform this into standard normal, for mean equal to 0, here Z become negative 1.5. So we are looking for this particular value. So how do we solve them? Are we going to use the first table or the second table? First table, middle region. Second table, upper tail table. Which one to use, class? Can someone guess? Is it the first table or the upper tail table?
First table.
Yes, first table. Why first table? Can someone please tell me why first table? Because we are using the Z value here, right? Upper tail table if you are given the probability value. Okay, so that's will be the difference when we use the upper tail table and when we use the first table. If you are given the alpha value or the probability value, then refer to your upper tail table. But now we are using our Z value. Okay, so from this we know we are looking for, if let's say 0, negative 1.5, smaller, so this reflect this particular 1.5, smaller, greater. So berapa kat sini kelas? It will be what? 0.5 minus berapa? From 0 until 1.5. Can someone tell me what is the value for this particular X region? From 0 until 1.5. What is the probability value? Shaded here.
0.4332.
Yes, thank you. 0.4332. So the value is 0.0668. Okay. What if you are being asked in terms of how likely that a student will score less than 350? How likely? Very unlikely. Very unlikely that a student will score less than 350. So that's how we interpret the probability value. Now, third question. Now, the third question, look at the question. So basically, most of the time when we ask student about these particular questions, the third question will determine whether student can get A or can get full mark or cannot get full mark. Okay, so let us look at question C. Remedial assistance will be given to student in the bottom 10%. Okay, please understand the scenario. If students are in the bottom 10%, they will be given remedial assistance. What is the maximum score for this group? For this group statistic? Okay, so the question asks you what would be the maximum of the lowest value of the math score for those students will get remedial assistance. If we draw again for C, this means that if you have your standard normal distribution, the bottom 10%, so this is 10%. 10% reflect the probability value. So 10% is equal to 0.01. Is it correct? 0.1 ke 0.01 eh? 0.1 eh? Silap eh? Sekejap eh? Okay. Okay, class, then what? You need to find the marks. Where is the position of the mark? This is the mean of the mark if we follow the standard normal. Then the Z alpha will be over here, and in this case we know that this is negative value. Okay, so how, class? To answer this question, formulate the probability terms. We know that Px, that will be the score marks, less than what value? We don't know. We don't know what is the value, Z alpha. So let's say we call this as maximum of the lowest value, equal to 0.10. So this will be your first notation of how you begin your process of finding the answer. Now, from at this stage, anyone got any question? if I draw the original distribution, the mean is 500. Let's say we don't know at what marks here. Okay, at what marks here, this particular student will get remedial assistant. This is for remedial assistant. If the student got this particular marks and below. Okay, so class, having said that, how to solve? We know that we need to find what is the maximum value. This maximum value reflect the Z alpha. Okay, so I don't think I need to write the Z alpha negative, just remain as Z alpha, where the Z alpha, if we transform this into standard normal, so this become PZ less than maximum minus the mean is 500 divided by standard deviation is 100, and this will give 0.10. Okay, we know that we are looking for this particular maximum value of the lowest value. So this is what we call as Z alpha, where Z alpha is given as maximum minus 500 divided by 100 equal to 0.10. Okay. So what does 0.10 tells you, class? We know that 0.10 is given by this particular region. What is the Z alpha negative value, class? What is the value here, class? Can someone please tell me? Class? 0.10. The upper table is the alpha is 0.10. So the second table 0.10. This is the value of the Z alpha, right, class? 1.2816. Okay, so for 0.10, the area of the alpha or the probability value, the Z alpha is 1.2816. So go back to your calculation. So this is given by negative 1.2, what? Just now, 2816. Okay, at this part, any question, class? Any question at this part, class?
Doktor tengok tengok table mana tadi saya tak perasan.
Since we are looking for, this is the probability value, right? So because we are looking at the, based on the probability value, that is alpha, alpha only reflect the second table. So the second table reflect the alpha value. We need to find the Z alpha. Even though that we know Z alpha is from the negative side, right? But for the answer, we are looking at the positive side. So alpha from the negative side is 0.10. So look for alpha 0.10. 0.10 is here. So that is why your Z here, this is all value for Z alpha. So your Z is 1.2816. 1.2816 for this part. But the alpha value is reflecting the negative value here. So the Z alpha also become negative. So that's why we have this. Okay, negative 1.2816. Okay, class? Is everyone okay? Okay, if okay, then we solve for maximum value because we need to find what is the maximum marks that require student for remedial assistant. So max become 100 multiply with negative 1.2816. Negative 500 bring to the right hand side become plus 500. So what is the max value here, class? Can someone please calculate? What's the max value? Class? Ada berapa ramai lagi tinggal ni? Macam tak ada orang je ni.
Ada doktor.
Ada.
Saya nak tengok sound.
371.
300, exact value 371.1.
371.84.
0.84. Okay, if you got this value, since we are referring to exact value, I mean round value, so max will be approximate to 372. Okay, then we know then the question mark or the marks that require student to for remedial class will be 372. Okay, so those who got 372 and below will have to go for remedial assistant class. Okay, so that's how we solve for this particular questions. Any questions so far, class?
Doktor,
Yes.
tadi saya tengok yang probability distribution ni,
Hmm?
masa yang kita buat the first one, kita kena cari tu dia different pula dengan yang last tu.
Yang B dengan C ke? You mean B and C? Is it B
Bukan.
and C or what?
Kan ada yang normal distribution yang doktor kata refer kepada table.
Yeah. Okay.
So
Then? You
memang
confuse kat mana? What do you confuse actually? Which part do you confuse?
kami memang kalau kata yang C ni memang kena ikut pattern tu je. Kena follow.
Bukan, it depends lah. If let's say you are looking at the bottom value, then the alpha value will be somewhere here. If let's say we are referring to this particular question, what will be the maximum value for those who will get, those who get, let's say, prize, those who will get prizes for those who score 90, let's say at the area, maknanya if let's say the next question is asking for the right, okay, means that what will be, let's say those students who are here will get prizes, for example. Okay, so what will be the value here? Let's say the prizes, if the students are at above 5 percentiles, means that the probability value is 0.05 here. So we need to find the maximum value or score for this particular what we call marks. Okay, so it could be at the bottom or at the upper tail table. So it depends on the question. If let's say the question asks for the lower value, it will be at the negative side. If the question asks for the positive value, it will be at the right hand side part. Okay, so my concern is that if let's say the question give you the probability value, so this is the probability value. So most of the time, if you are being given the probability value, then you will have to refer to the upper tail table. Okay, refer to upper tail table. But for question B, okay, you are being asked about the probability value. Find the probability value. Then this one refer to the standard normal table directly. Okay, so that is the difference between when to use the upper tail table and when to use the standard normal table. Okay, hopefully you get me correct. Those who just asked me. Okay.
Okay, dah.
Okay, thank you.